Interface. Interface is nothing but bunch of ports. So in SystemVerilog, you can define a component called interface, and within interface you can define all the ports. Conceptually, this is how interface works. Why we need to do this? Look at this. This is how we make the connections in Verilog or VHDL. So in Verilog or VHDL, basically we can make only pin-to-pin connections. This is good. It works for small designs, but if the design becomes pretty complex like SoC, we are discussing about Maven SoC. You look at this, there are so many interfaces and each interface will have hundreds of ports. So at the top level, if you look at, there will be thousands of connections. And the biggest challenge is debugging the source code. If you are going to make thousands of connections, obviously there will be a huge chance for making mistakes. And there will be too many bugs. And then the question is, how are we going to debug? That is where interface becomes critical. That's where SystemVerilog introduces a new concept called interface. Look at this. There are three modules, B1, B2, B3, and in Verilog, this is how you make the connection. But in SystemVerilog, you can think of making connection like this. It's going to be like one-to-one connection. And all the connections will happen in one step. How? You can visualize something like this. You have two adapters. One has all the male pins, the other one has female pins. In this case, the adapter has got hundreds of pins, but just by connecting these two adapters, you would be able to make all 100 connections in one step. Adapter with male pins, adapter with female pins. You would be able to plug in these two adapters, so eventually all the pins will be connected in one step. That's how interface works, and that's what critical for complex design like SoC. We have been discussing about this SoC. This SoC has got multiple interfaces at the top you look at, and the important question is, how are we going to connect all these IPs internally? You try to visualize the top level module. Here I am showing only 6 IPs, but in reality the SoC will have hundreds of IPs. Then would you be able to make port by port connections? Not possible. So what we do in SystemVerilog, we define interfaces separately as components. So here we have GPIO interface. If there is any input required like clock, this is optional. But the important thing is interface will have all the signals inside, or I would say ports. And for the ports, you can even define the directions also. How you want to use these ports for component like driver. For driver, obviously all the ports will be like output, because the driver has to drive the stimulus. So everything is going to be in this direction, output direction. So for the driver, we are going to define all the signals as outputs. For the monitor, we are going to define all the signals as input, because while driving the stimulus, basically the monitor is going to collect the values and then it will generate packet. So for monitor, all the signal directions would be input. But for the DUV, we want to use the signals as both inputs and outputs. So we will classify the signals. Let's say there are 20 signals, 10 would be output, 10 would be input. So you would be able to define direction for various components like this. This is how typically any interface would look like. Interface, end interface, and then interface will have all the signals, and then we define direction for different components, how we want to use these signals for different components. In this case, for our SoC, we need all these interfaces like AHB interface, AXI interface, SPI interface, GPIO and PIO interface. Like how we defined various packets, we are going to define interfaces also. Look at this. This is how we create the top level module for the SoC module, Maven _SoC module name, end module. and these are all various ports. AHB, AHB for DDR, AHB for DSP, AXI, SPI, GPIO, PIO. So these are all the ports of SoC. This is the bus. We instantiate same AXI interface and create the instance, and we are going to use this instance to make the connection. If you look at the right hand side, you see everywhere we are instantiating AXI bus. So that creates this structure. And in the left hand side, we make the connections. Look at this. This is microcontroller. Microcontroller will have two instances. One is external port, the other one is internal bus. So here AXI, this is the external port. Look at microprocessor. You are connecting the external port with AXI and then internal bus with AXI. So it has two ports. One is AXI, the other one is also AXI. Both are interfaces. So here we are making the connection like this. This is external port, this is internal bus. And similarly for DDR, AHB is the external port, AXI bus is the internal bus. This is how we instantiate all the IPs and we make the connections. Now the important point is you don't have the concept like interface. Here every port will have hundreds of signals. Think of it, AHB 100 signals, AXI 100 signals, SPI 100 signals. At the top level module, you may want to make thousands of connections, and that's going to be error prone. So the more and more connections you make at the top level, there will be a huge chance for making mistakes, and later on the challenge would be like how we are going to debug this source code. That's where we apply the concept like interface beautifully, and the connections would be like one-to-one connection. All right. Not only for the RTL, we may want to make similar connections even with the Testbench also. We discussed only about the RTL, how we can instantiate all the IPs and make the connections. That's where we looked at how we can apply the interface concept. Now, after creating the DUT, we have to connect the DUT with the Testbench. And the Testbench will also have all the interfaces, and it will have the components like GPIO generator, GPIO driver, GPIO monitor, AXI generator, AXI driver, AXI monitor. So within Testbench, you need to create all these components, and you have to connect all these components with each interface, and you need to connect each interface with DUT interface. So there will be too many connections. There also we can think of applying interface. So in Testbench also we use interface to make the connections. And the other important thing is this interface works only when you have similar ports. You can connect AXI with AXI, AHB with AHB, SPI with SPI, UART with UART. But you can't make connections like AXI to AHB. Interface will not work. Always remember this. That's why this can be applied beautifully for the SoC design. But if the design is going to have different kinds of protocols, custom protocols like protocol 1 to protocol 2, then the interface will not work. You always need to remember this. So how the Testbench top would look like. Look at this picture. The top level module is also Verilog module. In top level module, we are going to instantiate SystemVerilog test case. The test case will have the environment inside, and we also instantiate the DUT. Try to understand this big picture. You don't really need to worry about the lower level details. You can visualize something like how we can connect the SystemVerilog test case with DUT. Because eventually whatever the stimulus that you generate in test case, you should be able to drive the stimulus to the DUT. For that you need to make all the connections. And how we do that? We create a top level wrapper module, top end module. This will not have any port, And in this top level module, we define clock and we generate clock. Look at here. So at the top only we generate clock, and eventually the clock will be sent to design. In case of SoC, mostly the clock will be driven to one of the GPIO pins. One of the GPIO pin itself acts like clock pin. And then we instantiate all the interfaces: AHB, AXI, SPI, GPIO, PIO. These are all the instances because we want to make the connections. And the SoC has got the ports. You look at this. So SoC has AHB for DDR, AHB for DSP, AXI, SPI, GPIO, PIO. So we are instantiating all these instances as part of the port list. And this is the test case, SystemVerilog test case. SystemVerilog test case has got all the interfaces. So we are passing the same instances: AHB for DDR, DSP, AXI, SPI, GPIO, PIO. Here you look at, this is how the DUT is connected with the test case. It's like one-to-one connection. You can visualize order-based connection. And this is going to run the test case. So here there is no concept like interface. Again, you have to pass all the signals. It's going to be highly impossible. You cannot make the connections in terms of signals or ports. All right. So visualize the complexity of the Testbench architecture. Not only the top level connections within Testbench, look at this. You have to connect driver with the interface, monitor with the interface. We call all these components as bus function models. All the drivers and monitors. For every interface, there will be driver and monitor. There could be multiple monitors also. So you will have hundreds of drivers and monitors in the Testbench, and you cannot make pin by pin connections. That's where you really need interface concept. All right. We have been discussing about SoC Testbench, but to understand the concept, I want you to look at this simple example, memory example, how we use this interface. So you have this DUV, design under verification, which is memory. This memory has got two interfaces. One is write interface, the other one is read interface. So as part of the environment, we create generator. Here the same generator is going to generate both write packet and read packet, or optionally you can have write generator and read generator also. The design is simple, so we want to have one generator. And then we create drivers, write driver and read driver. How you connect the driver with the DUV? Through interface. So we instantiate the interface in both driver and DUV. And similarly, the read driver will be connected with the DUV through read interface. And you create monitors. The monitors will also be connected with the interfaces through interface. Look at this. So we use interface primarily to connect the BFMs, bus function models, in this case drivers and monitors, with DUV. Always remember this. And then the monitors will be connected with scoreboard, but in this case we use mailbox. You look at this, there are two possible ways how we make the connections. One is interface, the other one is mailbox. We use interface to connect the bus function models with the DUV. We use mailbox to connect the Testbench components. This is the difference. So to connect generator with driver, we use mailbox. To connect monitor with scoreboard, we use mailbox. Within environment, we use mailbox to make all the connections. But when it comes to connecting the environment with the DUV, we use only interface. Okay. And then the coverage model. coverage model can also be connected through mailbox, or you can use other features like callbacks. All right.